Looking at the Humboldt bus crash that took place at the intersection of Highway 35 and Highway 335 in Saskatchewan, and let's see what the physics tells us, what we can determine. We do know that the bus was traveling northbound and the semi was traveling westbound. There's a stop sign right here with a flashing light, and the collision happened on the southbound lane, and the bus ended up about here. Now, the bus, when it came to rest, had spun 180 degrees. It was pointing this direction. Okay. The other thing is that there's been some discussion about the trees, and if the truck stops at the stop sign, then the trees are not an issue. The bus can certainly see the truck, and the truck can certainly see the bus. If, however, it does not stop at the stop sign and does a rolling stop or fails to do it completely, then they can't see each other because of the trees. The trees would block their view. All right. So let's look and just see. We'll do some. We'll switch to Google Earth here. We'll do some calculations and see how fast. We'll try different speeds and different masses and see what the physics tells us. Okay. First off, I need to convert everything to kilometers per hour. From kilometers per hour to meters per second. So here I'll just show you here first. 100 kilometers per hour, because there's 1,000 meters in a kilometer, and there's 60 minutes in an hour, 60 seconds in a minute, so that's 3,600 seconds in an hour. It works out to 27.8 meters per second. So if you're doing the speed limit on both of those highways is 100 kilometers per hour. That's 27.8 meters per second. Okay, and I've got others here. There's the 27.8 that I just showed you, and if it's increasing, it goes up accordingly. Okay. All right. So let's first assume that the bus stopped, and that the semi stopped, and that the bus was speeding. There's no reason for it to speed. It's a perfectly clear day, perfect conditions. There's only 25 minutes from this intersection north to Nipawin, and it's only 25 minutes more to go. And it's not even 5 o'clock, and the hockey game doesn't start till 7:30. So there's no need to speed, but let's just suppose that it is. So if the bus is speeding, that's 130 kilometers per hour. Oh, one last thing first. I need to do this. From the stop sign to right there with the point of impact, if it came to a full stop, we'll say that to clear the full intersection is going to take more than 15 seconds. So we're just going to say about 10 seconds. That's our first rough estimate, is that to get from there, the stop sign, maybe move that up a bit, just past the trees. To get from the stop sign to the point of impact, about 10 seconds, and Google Earth tells me that's 30 meters. Okay, so if we know that it's 10 seconds there, then I can go by the speed of the bus, and I can see how far the bus is traveling. So if the semi takes 10 seconds to get from the stop sign to the point of impact, and the bus is traveling this, then the bus would have to cover that much distance during that 10 seconds. So let's go use Google Earth and see if we can see how far 361 meters would be. So from the point of impact, let's go down 361 meters. Well, I'm going to have a hard time making it. I'm only at 276 meters. 361 meters is pretty close to there. Straighten this out a bit. That's the best I can come up with. So if the truck stopped at the stop sign, it would be visible to the bus this entire time. The bus is speeding, and it has to cover all of this distance. It has to go past this one dugout, past another dugout, past a farmyard, and throughout the entire time, because conditions were perfect, the truck would be visible. So you're telling me that the driver, traveling at an excessive speed, covers all of this distance without any awareness whatsoever, completely distracted, completely unaware of what's happening, completely oblivious to the fact that there's a truck that he can see the whole time at the stop sign, moving through there, and they hit here. Okay, well, maybe he wasn't doing 130. Maybe he was only doing 120, in which case he would travel 333 meters. So let's shorten that up to 333 meters. Right, that's pretty close there. Now that's the distance the bus has to cover, completely unaware of a truck that's entirely visible. The trees would not be blocking at all, completely visible the entire time, and the bus is unaware. Well, maybe he wasn't going that fast. Maybe he was, let's slow him down to the speed limit. Let's say he was only going 100 kilometers per hour. This is 27.8 meters per second. He would travel a distance of 278 meters per second. Sorry, meters, 278 meters. So if he's going the speed limit, right there's pretty close. And at this point, you have to wonder too, okay, so again, he's doing the speed limit, but he's completely unaware. The driver is completely distracted, not paying attention, does not see the truck that would be completely visible. And the other thing too is you have to ask yourself, if the bus is here and the truck's at the stop sign, the truck is the one that does not have right of way. The truck has the stop sign. Why would it not see the bus and say, I'm never going to clear this entire intersection, I better wait? So that doesn't seem plausible. I don't think the physics supports the premise that the truck came to a complete stop. So let's go to premise B. The truck did not come to a complete stop, but the truck did a rolling stop. So from here to here, about 30 meters. Let's see how many seconds it takes at different speeds to travel that. I want to just see how close the bus would be. If the semi does a rolling stop, it has to cover 50 meters. So let's go here to my next sheet. So the truck has to cover 30 meters. Whoops, didn't mean to do that. 30 meters. Here are different speeds of the truck. Let's just go with a slow one. This 5.6, that is 20 kilometers per hour. If the truck slows down to 20 kilometers per hour, that gives the bus 5 seconds to react. And if the bus is going the speed limit and it has 5 seconds to react, the distance would be 149 meters. Let's see how far that would be. So traveling at 30 kilometers per hour, a rolling stop, the bus has 150 meters. What did I say? 149. 149 meters to react. That's a long ways. Plus, keep in mind that the truck would be visible the entire time that it left from this. Rolls through the stop sign, it would be visible. But that's the minimum. From the stop sign to there, the bus would have this much time to react. Now, there's no skid marks because the bus has ABS brakes. But wouldn't you think rather than have a collision, T-boning a truck, the bus driver would pull off into either this ditch where there's a field or this ditch and hopefully miss the trees? I think that's a long distance. So let's try a larger speed. Suppose the bus rolled through, what's 16.7? Let's go check out 16.7, 60 kilometers per hour. 60 kilometers per hour, that only gives the bus 1.8 seconds. 1.8 seconds. And if the bus going the speed limit, 100 kilometers per hour, has 1.8 seconds to react, then the distance from the bus to the impact is 50 meters. So the distance from the bus, right about there, that's the closest I can come. If the truck rolls through, what did I say? 16.7, 60 kilometers per hour. If it rolls through at 60 kilometers per hour, that's right there. That's how much room that the bus has to react. A split second, long enough to say, whoa, slam on the brakes, and some passengers at the back stand up and see what's going on. Gets worse if the truck is going faster. Let's just assume the truck is going 80 kilometers per hour. So 22.2 meters per second. That only gives the bus 1.35 seconds to react. And if it's going the speed limit, 100 kilometers per hour, and has 1.35 seconds to react, it's only 37.5 meters away from the point of impact. 37.5. That's the stopping, that's the impact for the what did I say, 1.35 seconds? 1.35 seconds, long enough to say, whoa, step on the brake, and then the point of impact right there. Well, let's suppose the truck is speeding. Let's suppose the truck is doing 110, 30.56. That gives the truck exactly 1 second, 0.98, to react. It would only be 27.2 meters away from the point of impact. 27.2 meters. 27, approximate, whoops, I gotta straighten it out. Approximately there. If the truck is speeding at 110 kilometers per hour, this is how much room that this is how far the truck is going to or the bus is going to travel after it says whoa and steps on its brakes. All right, part one, we considered basic kinematics formulas of physics, and we determined that if the semi stopped at the truck at the stop sign, then the bus, if you look here, the bus had in excess of 270 meters. And I think we have to ask about what's reasonable. If it's reasonable to assume that in this entire distance, the bus has no indication at all of a semi stopped at that stop sign and proceeding through the intersection. I don't think it's reasonable to assume that the bus driver, who has years and decades of experience, that he would be that inattentive. Okay, so the other scenario that we looked at using the kinematics formulas of physics is if the if the semi did a rolling stop, and we can see here at different speeds, and some of those speeds are quite low, like 20 kilometers per hour. We end up with the same conundrum in terms of if it's really slow rolling stop, then the bus has even up to 150 meters of warning, which is approximately there. Or if it's a faster rolling stop, like 70 kilometers per hour, which is 19.44, then you're only giving the bus, because of the trees there, you're only giving the bus 1.5 seconds, which only turns out to be 43 meters, which is pretty drastic when you look at it. Let me zoom in here. When you look at it, 43 meters, asking a bus driver to stop in that distance is problematic. Okay, that's part one, kinematics. Let's now go to part two, momentum, and this is where I think you're going to see where we have the most conclusive results that physics is going to tell us about this accident at this intersection. So let me just fine-tune the point of impact about right there in the southbound lane. And remember, it hit the, if I just show you here, the B train, it did not hit the tractor, it hit about right here. Okay? All right. Now, the bus got carried to its final resting spot of about here. Okay? So I'm going to create a right triangle. There's going to be a displacement vector in the x direction for the truck, and there's going to be a displacement vector in the y direction for the bus. And then we're going to use momentum. Momentum is a vector. So from there, let's just move it into the southbound lane. 37.5 meters. So my x vector, let's just go with 37.5 meters. And now let's do the y vector for the bus. Oh, about, it wouldn't be that far. It's about here. Let's go with 14.1 meters. I can square that up a bit, I guess, make it more of a right triangle. 14.4 meters. Okay, that's what I've got. 14.4 meters. So now what I need to do is I can use trigonometry, and I can get an angle. So I don't know if you can see my formula there. I'm doing the arctangent. So 14.4 is the opposite side, the y divided by x, which is 37.5. And I want the arctangent of that. It's about 21 degrees here. That should be 14.4 divided by 37.5. About 21 degrees. Okay, so that is a displacement vector. From there to there is a displacement vector. And momentum is also a vector. The bus had a y vector and the semi had an x vector. But it's going to have the same exact direction. The angle of the displacement, the resultant displacement, is going to be identical to the angle of the resultant momentum vector. And so I don't even actually have to use trigonometry anymore. I can just set up a proportion. So we have, what was it again? 14.4, 37.5. Okay. This is the bus, and this is the semi. Okay, well, let's make a proportion. The y vector on displacement proportional to mv for the bus. And we'll just assume that the bus, well, I'll put v for now. We'll assume that the bus is going the speed limit. There's no reason for it to speed. It's a perfect, conditions are perfect, but they're only 25 minutes from Nipawin, and it's not yet 5 o'clock. It's just a couple minutes before 5, and the game doesn't start till 7:30. There'd be no reason to speed. And this is for the semi. Okay, so I need to get some mass. So Greyhound, this is from Wikipedia. There's a charter bus. Whoops. Charter bus very similar to the bus that Charlie's Charters would be using. It says here that curb weight, the gross vehicle weight could be 40,000 pounds. Now that's just the weight, and we've got passengers. There's 29 passengers, but most of those passengers are teenage boys. They wouldn't be that heavy. So let's just, oh, I don't know. Let's go with about 46,000 pounds. 46,000 pounds divided by 2.2 should convert that to kilograms. Let's say 21,000 kilograms for the bus and passengers. Okay, so this, we're going to go with about 21,000 kilograms. And this we're going to say is 100 kilometers per hour. We can change that later if you want to. Okay, we need the mass of the semi, and then afterwards we can use this proportion to find how fast was that semi going. We can see if he was doing a rolling stop. We can see if he actually did a stop, or if he completely neglected it. Okay, so let's look at the B train here. Now it depends on the number of axles, and I don't know offhand by looking at it, but you can see here gross vehicle weight. Let's just zoom that in a bit. If it's got 5 axles, gross vehicle weight's about 40,000. This is not pounds, this is kilograms. 6 or 7. So I don't know, let's just say 50, like just go with a median value of 50,000 kilograms, I guess. Okay, so that's going to be 50,000 kilograms. Okay, let's fill it in then. We've got 14.4 over 37.5. That's on one side of the proportion. And on the other side of the proportion, we've got 21,000 times a speed of 100 divided by 50,000. And we're going to solve for v, which will be the speed of the semi. Okay, proportions are really easy. I can just cross multiply. It's going to be, it's going to be, this gets multiplied and these get divided. As easy as that. Okay. So 37.5 times 21,000 times 100 divided by 14.4 divided by 50,000. And how fast was the semi going at the point of impact? 109 kilometers per hour. 109 kilometers per hour. From the blue dot to the red dot. The semi, if he came to a full stop, somehow he magically attained the speed of 110 kilometers per hour from the time he left the blue dot to the time he arrived at the red dot. I don't think he stopped at that stop sign. I don't think he did a rolling stop. The only way that he was doing 110 kilometers per hour is if he did not stop at all. Well, I don't know. Maybe we did some assumptions wrong. Maybe the bus driver was speeding. Let's change that. Maybe the bus driver was doing 130. 130. Let's calculate it again. 14.4. Oops, sorry. 37.5. 37.5 times 21,000 times 130 divided by 14.4 divided by 50,000. How fast was the truck going? 142 kilometers per hour. See, momentum has to be conserved. And for the bus to be dragged from here to here, the truck has to be going as fast or faster than the bus. We can change the mass if you want. Maybe we made an error on the mass. Let's, I don't know, make the bus more massive. Just see real fast. 37.5 times 25,000 times 130 divided by 14.4 divided by 50,000. No, that's even worse. Let's make the truck less massive. Let's go with 42,000. Because now I've got the truck going 170, which would be unrealistic. 37.5 times 21,000 times, let's just put this truck back to 100 too. Or sorry, the bus. Bus is going 100. Divided by 14.4 divided by a less massive truck, 42,000. How fast was the truck going? 130 kilometers per hour. This is not looking good. No matter how I work with these numbers, I get a truck doing more than the speed limit. Let's reduce the mass here. Let's go to 17,000. $37.5 times 17,000 times, we'll keep the bus going slow, 100 times 100 divided by 14.4 divided by 42,000. Truck's doing 105 kilometers per hour. Okay, physics seems to be pretty consistent. At the point of the impact, the truck was doing 100 kilometers per hour to 110 kilometers per hour. And that's what physics tells us. And if that's the case, how much reaction time did the bus have? 100 kilometers per hour is there. He had 1 second. And at 1 second, he's 30 meters away. So when the truck is going 100, the bus had this much time to react. The bus went through the stop sign at full speed. Sorry, the truck went through the stop sign at full speed. The bus had very little time to react. That's what physics tells us.